Right, in the previous class we learned about why we need static route and then how to configure. We also learned about default route, but I did both in one single day, so I feel like there is something more clarity needed for you. So I'm going to repeat a few things which you may already understand. You might have already understood. You see, first scenario was we writing a static route on this router, considering this as a customer edge and this two as a provider edge. We wrote two static route, one towards the direction of PE1 to reach this network, the other static route to reach this network towards this direction. Later I said on the stub router you can write default route. When I say stub router, you should no more consider this as PE router, provider edge. You should not consider like that. When I say stub router, it means these routers all three are within your own network. They are within your own network.
So there are two sub-routers here.
Let me finish, please. Right, so we have like this. And in your organization, this is within your organization, you have three routers only. This is no way connecting to any service provider. I would like to call this as router 3 and router 2. Router 1. So we got only three routers and we want to write static route. We are not ready for dynamic routing protocol. So we write default route because this one and this one has got only one direction to reach unknown destination. Router A, if you take, router A knows about this 30 network, 30.2 is here, and knows about loopback. These two network and 30 network, it knows already. The unknown networks are 20 and this 111. All these unknown networks are only in this direction. That's why I call it a stub route. Similarly, for router 3, unknown networks are 30 and 2. All the unknown networks are in this direction. So instead of writing two separate line of static route, I can say any destination that you do not have route, you can follow this. That is what called as what? Default route. Okay, now you can ask question.
So a sub-router is if in the direct if all the networks are in unknown networks are in the one direction, that is called a sub-router.
Yes, if you have only one direction, which means you will have only one gateway. So for this router to reach all unknown network, this is the only hope. You have to send it here only. There is no other option. There is only one gateway. Whereas on this router, to reach this 2222, you have to go to this gateway. To reach 1111, you have to go to the other side gateway. This is not stub. Router 2 is not a stub router. because it has got unknown destinations in multiple directions, different directions. I cannot write a default route there. So you have to say, if you want to go to one network, go here. If you want to go to two network, go here. You have to specifically say, because the directions are different. But here, all the unknown destinations are only in this direction. So instead of saying to go to one dot network, go here, to go to 20 dot network, go here. If I have another 50 network, again saying to 50 network, same direction. Instead of saying repeatedly many lines, you can tell any destination that you do not know. For those destinations, you simply send it to router A2, RA2. That solves the problem. That reduces the line of code. Any question?
Yeah, no questions are understood. Because in both RA1 and RA3, for that you can just write next hopper router interface, so all the traffic will go through that way,
Yeah, router
and
A
there is
is
no need
IP
to
address, not
specify.
interface. Please, I want to correct. You can say
Okay,
router A2's IP address. Or you can
yeah,
say your exit interface, anyone.
yeah, exit interface, correct. Exit interface or IP address, correct.
IP address of the next router or this router's exit interface. Okay, fine. So this is what I was thinking that I should make it clear, and it is done. Now what is next? See the static route that we have learned. It is okay if you have few networks and few routers. Maybe let's say you have 10 routers, not more than that. Or you have only 5 routers in your organization, not much. And you have very few networks like 20 networks or 8 networks or 12 networks. It is easy to write routes, static routes. But the drawback is this. See, in this router we have said in order to go to 2.00 network, go to this address. What is that? 30.0.0.2. What if you change the address to 30.0.0.10? Then what you have written as a static route need to be modified. That's the drawback. That's the drawback. Another problem is, what if this loopback is removed? This static route will be still there in this router. And if anyone is trying to ping 2222, the traffic will come here and this guy will send here thinking that it is still available, but it is no more available. It's gone. When it is gone, this router need to be manually modified. That will take really long time. By the time there may be a lot of packet coming up to here and getting dropped because this is no more available. Or in a busy schedule, when you change your IP address to 30.0.0.10, actual IP address is 30.0.0.2, but after 6 months you change it to 10 for some reason, and you forgot that we have a static route here. That will cause problem. The traffic won't go because it is trying to send to 30.0.0.2. If anyone is pinging from here 2.2.2.2, this router is sending to 30.0.0.2. That doesn't exist. It's already changed to 10. So the ping never happens. Because it is after 6 months this is happening, you will not be thinking about those static routes that you wrote 6 months early, long back. So you will start troubleshooting. You will be thinking that may be the problem. You will go and uh, change the things which are really good, thinking that that might be the fault. So whenever there is a change in the topology, according to the change, the static route need to be modified. I just got only one router in the middle. What if I have 5 routers? You need to go to all 5 routers to do the changes, because in all 5 routers in the middle you have written route for this network, but this network has gone down. Now you need to go to every router. Here no problem, here it is a default route, but in the middle you have a lot of routers. You have written, they are not stub routers, you have written precise static routes to reach 2222. Now you need to go to every router, remove the static, which is slow in convergence. This really takes a long time for convergence. Slow in convergence. What is convergence? Adapting to the change, topology change. It takes time. Someone should report saying I'm unable to reach 2222. Then you will go and see 2222, someone has removed that loopback interface. Then now you have to go to every single router, because you may not be allowed to configure that loopback interface on router A1, RA1, because for some reason they said remove, we don't want. Now you have to go to every router in the middle, or this may be a physically connected LAN, and now they say we don't want that LAN anymore, we don't want this LAN. So that network which you were having in the LAN earlier had a static route. Now you need to go to every router to remove that static route. If not, the routers will be keep on forwarding. If you will remove, then packet won't be keep on coming. Right here you have removed, because you have removed here, traffic will come here, and this guy will say, because you have a default route here, the traffic will come here, and this will say sorry, there is no route, and it won't go further. Got dropped right here. Right. So in short, if your network is smaller, under your eyesight, everything is happening right in front of you, then you can immediately go and do the changes. That won't be a problem. But when you have a big network, we need to think twice, because convergence time is going to be high. In a large network, packets will be going from here to there in thousands, and when a network goes down, the other routers are not updated, and they will be keep on forwarding those thousands of packets, hoping that it is still there. So we need to switch to dynamic routing protocol in order to make the convergence dynamic. When the convergence happens dynamic, then there won't be a struggle. There won't be a huge loss. Because as soon as some change happens, for example, when I change this address, why is this address here? Okay, now let me copy. Now when I go and change this address to 30.0.10, immediately the protocol will intimate this guy, hey, the gateway is changed. To come to 2222, you should send it to 300010. Then this router autocorrects in the routing table saying 222 network, I need to send to 300010. You see, if I change into 9, immediately here also the change will happen. If I go to this interface and change it into 8, then immediately in the other routers it will change to 8. So depending on a routing protocol will be a better choice than writing static routes. In a large environment, dynamic routing protocol is good. In a small environment, you can write static routes so that you can avoid the CPU usage that the routing protocol will consume. See, definitely protocol consumes CPU. Routing protocol, if you enable instead of static route, if you enable a dynamic routing protocol, they need to discover, they need to update, they need to keep checking whether there is any change. If there is a change, immediately they need to update. For this, all bandwidths and CPUs will be consumed. Those are all additional CPU, additional bandwidth, additional CPU and additional bandwidth. If you need them, if you are okay with that, then you can go for dynamic routing protocol. Actually, it is okay. When compared to the damage that we will have because of the static route in a large environment, the packets are coming and getting dropped, meaning they consume the bandwidth, the CPU, and they come all the way and then getting dropped. That is very bad. Compared to those damages, the CPU utilized by a routing protocol, the bandwidth consumed by the routing protocols update, they're far better. So in a large environment, we take time to identify that there is a change and update. Better go for dynamic routing protocol. In a small environment, everything happens right in front of you, so it is easy for you to go and immediately change. You can go with static route. Doing that, you can save some CPU and bandwidth. So, dynamic routing protocol is best for large environment. Now, there is a drawback again. Writing a static route in a large environment, that's not a recommended one. The reason is, in a large environment, understanding the topology in depth is mandate. Only then you can write a static route. See, you need to know where, on which router, what network. You need to know every single portion of the network. Every single portion of the network you need to know in order to write static routes. So the knowledge of the topology, the complete design you need. If not, then you cannot write the best route. Sometimes the routes that you write may be a long route when the knowledge of topology is not complete. When it is incomplete, when you don't have a complete knowledge, a clear knowledge, in-depth knowledge of the topology, you may write a route. The route may be valid, but still it is not the best. For example, I want to go from Bangalore to Mumbai. going to Delhi and Delhi to West Bengal, and then West Bengal to Telangana, Telangana to Mumbai. That is also a route. You can write route like that. But that's not the best route. So when you do not know the map of India, when you don't have the picture of India, when you book the airline ticket, you may not be aware of this. You may think like, okay, going to Delhi and West Bengal and Telangana means Pune, sorry, not Pune, what is it? Whatever. And then Telangana and then to Mumbai. Cheaper price, only 6,000 rupees. And how many stops? 3 stops. But when I see another airlines which shows direct Mumbai, that shows 25,000. Right? This is 6,000 only, man. That is 25,000. So let me go with the 6,000. But you do not know that it's a long route. It's going to take a lot of hours. So when you do not know the complete map of topology, you will not be able to write the best route. So knowledge of topology, if it is lagging, then better go for dynamic routing protocol. The protocols, they discover the best path and they put the best path into the routing table. Yeah, they have the discovery mechanism. Dynamic routing protocol can discover and find the best route and put the route into the routing table. So best go with the routing protocol when you have limited knowledge of topology. When the topology is big, it is good. And whenever you want fast convergence, it is good to go with routing protocols rather than static route. Now, I have given you a clear picture of why we need a dynamic routing protocol. Do you have any question on this? What are the routing protocols we have? See, we have broad classification routing protocols. Routing protocol has a two broad classification. One is IGP. The other one is EGP. IGP stands for Interior Gateway Protocol. Interior Gateway Protocol, or the protocol within autonomous system, within an organization, within autonomous system. EGP protocol, Exterior Gateway Protocol. These are between autonomous system, meaning it is between your office and your next office, or your office and the service provider. Now, within the organization, within the autonomous system, the routing protocols are called as IGP, Interior Gateway Protocol, but this is not the name of a protocol. This is an overall name, IGP, Interior Gateway Protocol. So the name of the protocol is like this: RIP, Routing Information Protocol. Routing Information Protocol. Enhanced Interior Gateway Routing Protocol. Open Shortest Path First These are the three that we will be dealing with in CCNA. But again, not that in depth like what you have in CCNP and CCIE. Every topic repeats again, but in more deeper sense in all levels. We'll also learn about the other protocols in CCNP and CCI level, like BGP. BGP comes under EGP, Border Gateway Protocol. BGP stands for Border Gateway Protocol. OSPF stands for Open Shortest Path First. EIGRP, Enhanced Interior Gateway Routing Protocol. RIP, Routing Information Protocol. Now there is also another protocol in IGP, which is a service provider only protocol called ISIS, Intermediate System to Intermediate System. That's again not in the enterprises level. You will see only on the service provider side. Right? We don't learn in this course here ISIS. Also about BGP. Maybe I'll give some introduction to BGP, but BGP actually starts in CCNP level. Right. So the routing protocols, we have many. That's what you need to understand. We are not just having one protocol as a routing protocol. We got many. For example, if you're going somewhere new place, what do? You open Google Map. In Google Map, you have multiple options. Going by four-wheeler, going by public transport, going by a bike, and also you will have a filtering option. Filter all the routes that has got toll. This all needs different protocol. Yeah, not the same protocol can be used for all this purpose. If you want to go really in the shortest path, never mind whether toll is there or not, I want the shortest and earliest reaching path. For that, you have one algorithm, shortest path first algorithm. You say, no, I don't care about how long it takes. I want to go in a road where there is no traffic or less traffic and there is no toll. Then there is another algorithm to find that for you. Likewise, in networking, to find the path, you will have different expectation. In networking, to find the best path to reach some destination, you may have different expectation. According to you, the best path is the path which has got low cost. But according to the other guy, it may not be a low cost. For him, the best path is the path which is going to take me early. See? That's what policy. That's what expectation. So when we learn all these protocol, we will know which protocol suits our requirement. And we'll enable that in our environment. So in our next class, we are going to start with this very first protocol called Routing Information Protocol, RIP. And what we have learned today is the importance of routing protocol and different classifications. IGP is within the autonomous system, within an office, within an enterprises. EGP, between enterprises, between autonomous system. Do you have any question? See you.